Hello my dear students, welcome back to my channel Maths Classes. So as you all know that your board exams are very close, so in this video I'm gonna revise the important theorems from the chapter Triangles so that it can help you to score good marks. So let's start. So this is our first theorem. This is basic proportionality theorem BPT or Thales theorem. So students, in your board exam either they can ask you by Thales theorem or simply by BPT. So both are same. So here the statement is, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. So what does it mean? You can see here a triangle ABC. So if a line is drawn here, DE is the line. So if this line is drawn parallel to the third side of the triangle, then the same line will divide the other two sides in the same ratio. Got it? So here we will write the given part. So always start by writing the given part. So here given that DE line is parallel to BC. So DE is parallel to BC and we have to prove that the side ratio are equal, right? So we will write down AD by DB is equals to AE by EC. So this is the thing we have to prove. So before starting the proof, we need to do some construction work. So here some constructions work we will do. We will join B to E and D to C. So here with the help of scale you will join. So here directly I am joining these two lines. This is BE. And here we need to draw two perpendiculars. So let us draw the first perpendicular. This is the first perpendicular and we can name it as M, and in the similar way this is second perpendicular. Understood? So now the same construction work we are going to write here. So by construction we'll write join BE and DC and draw EM perpendicular to AD. Draw EM perpendicular to AD. In short form I'm writing, okay, this is the symbol of perpendicular. Draw EM perpendicular to AD and DN perpendicular to AE. So now let us start the proof. This is the proof. So here for proving this theorem we need to find the area of triangle. So as we know the area of triangle is half base into height. So the same formula will apply in triangle ADE and in triangle BDE. See here students, first of all we will see the side AB, right? So for the AB side there are two triangles. The first triangle is ADE and the second triangle will be BDE. Right, it means this ADE triangle is lying on the base AD and this triangle BDE is also lying on the base BD, which is the same side AB, right? So first of all we need to find the area of triangle ADE. So as half base into height, so half. Now base is AD multiplied by height will be EM. Understood? This is your equation number 1. In the similar way, we will find the area of triangle BDE. So area of triangle BDE is again half base into height. So this side base will be BD. Now for this triangle, for the base BD, height will be same. Height will be same EM, because height is always considered as the perpendicular distance, right? So height remains the same and this is your equation number 2. Now dividing 1 and 2, if you divide equation 1 by 2, so what will be our answer? We see here, see in dividing both the equations half and half cancel out, right? In the similar way EM and EM will also cancel out. So what is left? AD upon BD. So the same thing we will write down here. Therefore area of triangle ADE divided by area of triangle BDE is equals to AD by BD. And now finally this is your equation number 3. Understood? Now the next step, in the similar way, now see here students, just now we have taken these two triangles, triangles ADE and triangle BDE. Why? Because both the triangles are lying on the same side AB. Now we will take the side AC. So for the side AC, we need to take triangle AED. This is the same triangle ADE, and the next triangle will be DEC. Understood? So now again we will find the area of triangle ADE. So area of triangle ADE is again half base. Now for this triangle ADE, now we will take the base as AE. So AE multiplied by, and for the base AE, our height will be DN, right? So multiplied by DN. And now we can name this equation as equation number 4. In the similar way, we will find the area of triangle DEC. So area of triangle DEC is equals to half. Now again for this triangle DEC, base will be EC. And for the base EC, height will be the same perpendicular line. Understood? So here DN will be the height. And this is equation number 5. So the same step, we will divide equation 4 and equation 5. Right? So after dividing both the equations, again half and half will cancel out. DN and DN will also cancel out. So what is left? AE by EC. So therefore area of triangle ADE upon area of triangle DEC is equals to AE by EC. And now this is your equation number 6. Now see here students, now you got equation number 3 and equation number 6. So this is your final equation 3 and equation number 6. Now you need to compare only equation 3 and equation 6. So if you see this left hand side, okay, this is your LHS part and this is your RHS part, same here. So if we compare the LHS part, so this is area of triangle ADE, there is also area of triangle ADE, and maybe both are same. But in the denominator, this is area of triangle BDE and this is area of triangle DEC. So if I say that these two triangle area are equal, yes, both the triangles area are equal. Why? Because if we see in this triangle ABC, you see both the triangles, triangle BDE, this is triangle BDE, and the next triangle is DEC, and this is our triangle DEC. So one thing, if you have noticed here that triangle BDE and triangle DEC are lying on the same base DE, right? You see both the triangles BDE and DEC are lying on the same base D, also between the same parallel lines. So there is one property that when two triangles lying on the same base and between the same parallel lines, then the area of both the triangles are always equal. So the next step will be, so since area of triangle BDE is equals to area of triangle DEC. Why? And here the reason is that triangles lying on the same base, triangles lying on the same base and between the same parallel lines, and between the same parallel lines are always equal in area, right? So from this concept we can say that this LHS side of equation 3 and the same LHS side of equation 6 are equal, right? Because all the triangle, this BDE and DEC is also equal, so anyhow this LHS part is equal. So therefore AD by BD is equals to AE by AC. This is the only thing we got. So from equation 3 and equation 6 we can easily write down AD by BD is equals to AE by EC. Hence proved. So this is the only thing we need to prove. So moving to the next theorem, that is converse of basic proportionality theorem. So this is the converse of BPT theorem. In BPT, the lines were parallel and we have to prove that the ratio are equal. But now in the converse, it will be totally opposite. So here the ratio will be equal. It will be given to us and we need to prove that the lines are parallel. Understood? So here the statement is, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Correct? So we will start from the given part. So given that the ratio are equal. So we'll write the given part, AD by DB is equals to AE by EC. Now after the given part, we need to write to prove. So here we need to prove that this line segment DE is parallel to BC. DE is parallel to BC. So now we'll start the proof. So again, before proving it, we need to do some construction work, right? So here in this triangle, what we will do, we'll draw a line segment DE dash. We'll name it E dash, which is parallel to the third side BC. Okay. So here construction work. So by construction, we'll write draw DE dash parallel to BC. Now we'll start the proof. So these are the basic steps you need to follow. So here we'll start the proof now. So here as by the construction we have drawn DE dash parallel to BC. So we'll write here, since DE dash is parallel to BC, therefore, so whenever two lines are parallel in a triangle, so can we say that the ratio are also equal by BPT? Just before we have proved. So therefore AD by DB is equals to AE dash by E dash C. See here students, we will take this point E dash because we are taking the line segment DE dash, not DE, right? So we will take these two sides, AE dash upon E dash C. This is the equation number 1. Also, from the given part, so from the given part, what we have, we can see here AD by DB is equals to AE by EC. This is from the given part, correct? Now we will compare. So comparing 1 and 2. So after comparing 1 and 2, so what we will get? We can see here that this LHS part both are same, right? So comparing 1 and 2, what we got? AE dash by E dash C is equals to AE by EC. Right? We got this. So after this, now we have to add 1 both the sides. So adding 1 both sides. So if we add 1 both the sides, plus 1 is equals to AE by EC plus 1. Now after LCM E dash C, so numerator it will be AE dash plus E dash C is equals to AE plus EC whole upon EC. Right. So what is this AE dash plus E dash C from this triangle? AE dash plus E dash C is the whole line segment AC, right? So directly we write AC by E dash C is equals to, in the similar way, AE plus EC, correct? This is again the same line segment AC. So AC by EC. Now you can see here AC and AC cancel out, both are same. So what we got? 1 by E dash C is equals to 1 by EC. So finally what we got? That E dash C is equals to EC. So this is only possible when this E and E dash both lie on the same point, or we can say that E and E dash coincide. So therefore E and E dash coincide. So therefore we can say that if both the points coincide, E and E dash, then we can say that DE is parallel to BC. This is the only thing now which you need to prove. So hence proved.